Of course, one of the reasons why we need better, larger telescopes that are more sensitive and that can survey wider areas in the sky is because there is really so much to still discover and understand about our universe. And I will try to give you some highlights of things that I think will definitely be hot topics. Some of them are already hot topics now, but they will become even more once we have the facilities to actually explore these topics in detail. Personally, I think that finding and understanding the very first generation of stars, something that we call population 3 or POP3, is going to be something that is both very hard and challenging, but incredibly exciting, and that we might be able to do. Some people actually believe that we'll never be able to see the pure population 3 stars, and I think that we will, and perhaps this video might be seen at an epoch where we've already been able to find population 3 stars, and then I can claim that I've said it first. There are, of course, many open questions about first-generation stars. For example, how massive were they really? We expect many of them to have been very massive, but is that the case? Also, how much heavy elements did they actually form? And for example, what is the percentage in our bodies that actually comes directly from first-generation stars? This can only be done if we really understand the distribution of masses of first-generation stars and, for example, their lifetimes. Furthermore, recent simulations actually show that first-generation stars, not all of them were very massive. Some of them might have formed in sort of a planetary system mode, but that instead of forming planets around a big population 3 star, you can form smaller population 3 stars. And if that is the case, some of these low-mass POP3 stars might have survived until the present, and therefore the halo of our galaxy might be the place to look, and we might be able to find them there. Of course, with James Webb, the field will have a huge boost because it will allow us to try to find these population 3 stars at the very early universe, but it might well be that they are so rare, or they only live for such short amount of times, that even with James Webb, we won't be able to find them, and only following generations of telescopes will be able to find population 3 stars. Another really important question that we don't know the answer for is whether, at least in some galaxies, stars or black holes, which ones actually came first. It is very likely that the first black holes formed out of the remaining cores of first-generation stars when they exploded the supernova. However, we don't really know whether the relation, that very tight relation between the mass of the black hole and the mass of a galaxy was already there to begin with when the first galaxies actually started forming. And we know that it is possible that at least for some galaxies, some supermassive black holes might have formed directly from a big gas cloud of something like 1 million solar masses, something that people refer to as Dirac collapse black holes. And with the new facilities and over the next few years, we hope to find more evidence for the presence of those Dirac collapse black holes, or perhaps for the fact that they never existed. And that will constrain both the models that exist now and our understanding of how supermassive black holes form and evolve. Of course, the next few years will certainly be dominated by a lot of news, not only to do with discoveries of Earth-like planets, but perhaps more importantly, with what their atmospheres contain. There's lots of people and new facilities, and this includes the James Webb Space Telescope, that will try to study some of the best candidates for being habitable, to try to look and find any evidence for life. So it is possible that over the next 10 to 20 years, we will find direct evidence of habitability, or perhaps even signs, even if they're indirect signs, of life existing in other planets beyond our own. And on top of that, there will also be lots of missions to our own solar system, especially to the moons of the gas giants, where conditions for life may exist. And perhaps we will find life away from the Earth in our own solar system before we find any evidence for it in extrasolar planets. Beyond extrasolar planets, there's also lots of questions to do with the role of large-scale structure, and also to do with AGN and AGN feedback. We really need to know whether structure is really just set by cold dark matter. We think it is, but we really haven't measured it or imaged it directly. And there are experiments going on to try to do this, to really image the cosmic web. And we also have an idea of what is the role of the cosmic web, but is it exactly as we expected Or will that unveil details of, for example, how galaxies are influenced by their environment? And of course, we need to understand how AGN feedback really works and whether it really does what we think it does in terms of keeping the most massive halos shut down. But the other thing that we don't really understand is how can we have such massive, supermassive black holes so early on in the universe? Related to AGN feedback, the other really important question that we still don't know the full answer is what actually quenches galaxies. And we've seen that supernova feedback is really important for low mass systems. AGN feedback seems to be the most important for the massive systems, but the physical details are still pretty much unconstrained. We're getting better at it, and simulations are crucial, but there are a lot of questions that are still unanswered, such as the connection between these two kinds of feedback that perhaps work so well because they might work together.